Hello, so we're going to go through the forces on a spring, required practical, and hopefully we're going to go through it in enough detail for you to earn some marks. Effectively, what we've got here is two clamp stands, one with a ruler attached to it. I have done a little bit of a pre-test to check that everything's going to fit on that 30 centimetre ruler. If not, you could use a metre ruler. My spring attached to this clamp stand just hung on there. I've got a stack of masses. I'm going to do 8 masses, and each of those is roughly 1 Newton each. I'm also going to do the same with an elastic band to see how that compares. I'm not going to have mine hanging off the edge because I know that it's going to get just about to that ruler line, but you could do that as an option. Obviously you then just need to be careful that nothing's going to fall on your feet because you will have hanging masses. I'm going to have to put some weight on this at some point to stop that from toppling over as well. It's a safety thing that we need to think about, and I'm going to be good and wear some safety glasses just in case the spring pings off the end there. So first thing we need to do is measure the length of our spring with no force attached to it, with no force hanging off it, and I make that 2.2 centimetres. So we need to write that down in our 0 row. Obviously that's no extension, and that is the number that we're going to be taking off every time in order to complete this practical properly. All that we're going to do, just as a general before I do start, we're going to hang 100 grams at a time, so 1 Newton at a time on that spring, measure the length, and then we can calculate the extension afterwards, plot that in a graph, and hopefully it will show the pattern that Hooke's law follows. So make sure you write down these results as we go through. So each one of these plates is 100 grams, roughly 1 Newton. And we're going to measure the length every time, take the original length off it, and then we'll have our extension to plot on our graph. So the length with 1 Newton on it between the bits that look like key rings, I would say is 4.6. 2 Newtons. $7.9. 3 Newtons. 11.5. 4 Newtons. 14.8. 5 Newtons. 18.1. 6 Newtons. 21.4. 7. 25.0 and 8 newtons. 28.2. So that's the spring finished. A little bit more work to do before we can plot the graph for the spring, because we need to work out the extension. So calculating the extension means taking off our original value of 2.2 from every result. So that would give us what we need to plot on our graph, and we'll do that in a second. So we're now going to do the same for the elastic band. I might need to change my ruler up here. Move that a little bit further up, because the elastic band is going to start almost exactly in line with the clamp. And the original length of the elastic band is quite difficult to get, because you want to straighten it out but obviously not stretch it. So I would say that is roughly 8.7 with no weight acting on it. And we're just going to do the same as we did before, adding on 1 Newton every time, measuring the length, and then taking off that original length with no weight on it to work out our extension every time. And we should be able to plot these all on the same graph to compare them. So 9.5 with 1 Newton on it. Needs to make sure it's hanging a bit more free than that, I think. 10.3. 2 Newtons, 3 Newtons, 11.8. 4 Newtons, 13.6, 5, 16.0, 6 Newtons, 18.3, 7 Newtons, 20.5, and 8 Newtons. Always amazes me how much an elastic band can hold in reality. $22.5. So a bit of simple maths to do now. Taking off the original length from both the spring and the elastic band to get the extension. So we'll go and do that. Okay, so to calculate the extension, really simple. We just do our spring length for that weight, take away our original spring length with no weight on it, which was 2.2. So 4.6 take away 2.2, 2.4. 7.9 take away 2.2, 5.7. 11.5 take away 2.2, 9.3. 14.8 take away 2.2, 12.6. 18.1 take away 2.2, 15.9. 21.4 take away 2.2, 19.2, 25, take away 2.2, 22.8, and 28.2, take away 2.2, give us a nice round 26 to finish. Okay, so just like we did before with the spring, we need to subtract our original elastic band length with no weight on it from each of our lengths with weight on it to work out the extension. So 9.5 take away 8.7 give us 0.8. 10.3 take away 8.7 would give us 1.6. 11.8 take away 8.7 would give us 3.1. 13.6 take away 8.7 would give us 4.9. 16 take away 8.7 would give us 7.3. 18.3 take away 8.7 would give us 9.6. 20.5 take away 8.7 would give us 11.8. 22.5 take away 8.7 would give us 13.8. On to some graph plotting. Okay, so we need to start thinking about how we're going to plot this graph now. It will be a scatter graph with a line of best fit for both. And I think it's probably best to plot them both on the same set of axes if we can. If you struggle, by all means, do them on two different sets of axes. Let's do spring first. So weight is our independent variable. That's what we changed in the investigation. So that will be going on our x-axis. Spring extension or just extension will be going on the y-axis as our dependent variable. So 0, 1, 2, 3, 4, 5, 6, 7, and 8 newtons of weight on the x-axis. And then make sure it can fit. I think 5s will probably be sensible for me. Just double check what you're doing on your piece of paper. And that will be extension centimeters on there. So for the spring, obviously use your scale. My tiny boxes on mine are very tiny, so I'm going to do some estimation. But got a point for 0, 0 with no weight on the spring. There was no extension. 1, we're talking 2.5. 2 newtons, 5.7. 3, 9.3. 12.6. 15.9. 10.2. Again, I am estimating mine, so make sure you plot yours really, really carefully, really accurately. And you should be able to see quite clearly that my line of best fit is a straight line. And I'm going to do my best to do this with a ruler. Not bad at all. So that was for the spring. And I'm going to change colour to help me do the elastic band. So again, point on 0, 0. 1 only gave me 0.8 extension. As you can see, does not go up that much to start off with. Again, draw your points really accurately. Mine is just going to be a bit of estimation due to the size of my graph scale. And as you can see with this one, we have kind of a curve with maybe a bit of a plateau coming. So very rough curve drawn for the elastic band. So with this, we can see that the spring follows what we call Hooke's law, in that the extension is directly proportional to the force applied. It goes through the origin, it's a straight line of best fit, and the elastic band does not follow Hooke's law, so we call it non-Hookean, which is an amazing word.